So this week we have studied about the concept of sampling distributions. So now we will implement those concepts on the OTT platform dataset. And the first thing that we are going to do now is that we will see how to obtain the sample statistics, that is sample mean or the sample variance, sample median or the sample range. So these how can we obtain from the dataset using Python. So for this we will first import the necessary libraries. As you know, we are going to import pandas as PD. Okay, so this will be used for your data analysis and data manipulation. We will also import NumPy, which is used for numerical computations. So now import NumPy as NP. Now we will basically use the pandas to read the CSV file, that is our OTT perception data, and store it in this variable, that is data. So from pandas pd.read underscore CSV OTT underscore perception underscore data dot CSV. So now we will set the sample size. So we can suppose set the sample size to 100. So this basically means that we want to randomly select 100 data points from a column. Suppose in this case, let us see for the age column. So here this means that we are going to randomly select 100 data points from the age column of the data set. Okay, so you can change it according to your problem size. So now we will use this method over here, dot sample method, which is basically provided by pandas in order to randomly select. So let us write the code for that. So from this data frame that we have, from data we will extract your age column. We are focusing on that, and then we will apply the sample method over here, which is used to randomly select 100 data points from the age column. So we will write in this the sample size, that is n. We have already defined n as 100. So we'll write that, and also we will mention random state as 42. If you can recall, last lecture also we had this random state as 42, which basically ensures that reproducibility will be taken care of if you are using this random state as 42 or 123, anything that you want to use over here. So basically, since here also we are drawing a random sample, and if you do not want the random sample to get changed every time you run the code, so that is why we give this number over here. Now let us find the sample mean. Sample mean, for this we will use the NumPy library, and from there we will use this function, mean function. Mean in sample we already have this. Okay, so let me just see what is this sample mean. So it gives the value 42.55. So this is the sample mean, the statistic that we studied, I think. So if you can recall, 1 over n summation xi. So first of all, we have decided that what will be the sample size, and then from this particular column we have sampled 100 data points and calculated the mean for that. You can likewise take any other column and also vary this sample size as well. The next statistic that we saw was sample variance. So sample variance can again be found out using the NumPy libraries var function var, and here we write sample as well. Here we write DDOF is equal to 1, which is basically your degrees of freedom. So this is delta degrees of freedom. Here we fix it as 1, which basically means that we are talking about the sample variance. It is not the population variance. If you would have been interested in population variance, you would have mentioned here 0. Okay, so if DDF is equal to 0 you mention, then it will calculate your population variance. Otherwise, if you keep it as 1, it will calculate your sample variance. And if you can recall, we had this, the difference between the sample variance and the population variance, the difference in their formula is just the denominator is different. Okay, so instead of n, you divide the sum of squared differences by n in the population variances. Otherwise, if it is sample variance, you divide it by n minus 1, because then it will be an unbiased estimator. So here we are basically specifying that we want the sample variance. So let us see what is the answer to this. It is 127.78. Likewise, we can calculate sample median also. Sample underscore median we can write. So we will again use this numpy's median function over here, and we can just simply mention sample. So what is the sample median? It is 44. Okay, so median and mean are very close. And finally, we write the sample range, sample underscore range, which will be NP, again the NumPy library, and from here we will use this max and min functions, max of sample minus NP dot min of sample. Okay, so if you find out this, it is 40. Okay, so you can print these sample statistic also, and you know the usual command. I can just write it for one of them, so you can likewise do it for the rest of them. So if you want to suppose print the sample mean, so you will write it in this way, sample mean. So you can put a colon also if you want. So it basically depends how you want your output to look like. Accordingly, you can do the customization over here. So if you write sample mean, because this is the variable in which we have stored the sample mean, so if you run this, you will get this, like sample mean is coming and then a colon is also coming as we wanted. If you remove this, it will not come. Okay, so if you just see over here, it will go away, but it would be better if you specify it. So sample mean is 42.55. Likewise, you can print other statistics also. So here what we have done is basically we have loaded a data set, we have randomly sampled 100 data points from the age column, and then we have calculated different sample statistics. So now we are going to find the sampling distribution of the sample mean. Okay, so we have seen that this is the first topic when we were talking about the sampling distribution. So let us see how do we do that. So again, as we have already imported pandas and numpy library, so we need some additional libraries. So let me just write their names. Import matplotlib. So here this would be used for creating plots, matplotlib and pyplot basically from here as plt, and then we also import, you will use the scipy library from there. From scipy's stat module, scipy.stats module, you will import norm. Norm basically, this function is used to draw the normal distributions, to work around with the normal distribution. So that is why we import it from your scipy library. Okay, so we have already loaded the data set here. If you want, we can do it again. We can just mention it, or I can write it here df. Okay, now we define the sample size and the number of samples that we want, because in sampling distribution you have seen that we take samples of different sizes. Okay, and as we keep on increasing the sample size, your population distribution becomes normal, right? So that was in your central limit theorem. So here first we will say the sampling distribution of the sample mean, then we will move on to the central limit theorem. So here we will first define the sample size and the number of samples that we want. So let sample size be sample size is equal to 50, and the number of samples basically that we need is num dot samples is equal to 1000. Okay, so we are setting it to sample size as 50. It means that we are going to draw a sample of size 50 each time. Okay, and how many samples are we going to take? We are going to repeat this process 1000 times. Okay, so 1000 samples will be drawn and each sample would be of size 50. Now we will create an empty list over here that will store the sample means. Create an empty list to store the sample means. So here, let me just write it. Sample means is equal to just this. So this will basically create an empty list. Okay, and the sample means will be calculated at each iteration now, and then it will be added to this list. Okay, so that will be no longer empty. So for this, we will create a loop that iterates these many number of times, that is 1000 samples we want. So it will iterate these many number of times, and in each iteration it will take a sample, calculates its sample mean, and finally it will append it to this list over here. Okay, so at the end of 1000 iterations it will no longer be empty. Okay, so we will now write a for loop for this. So for I in range num underscore samples. So basically you can instead of I, this is the variable name that I am using, you can use anything else also. So here we are saying that it is going to iterate these many number of times. So range, why we are writing? Because it will generate a sequence of numbers that will start from 0 and it will go up till num samples minus 1. So the range will be calculated in that way. For this, now we are going to draw a random sample of size 50 from this data set. So we will store it in sample is equal to df dot sample, and we will write the sample size as we have done earlier also. Here, if you can recall, we have used this sample function, sample method. So here also we are using the same thing. Once we have drawn the sample, we will calculate the sample mean. So for this we will write sample underscore mean. This will be basically sample. Here we will be focusing on age dot mean. So it will calculate the sample mean for this particular column. So basically from age, a sample would be taken, and whatever sample has been taken, for that the mean will be calculated, and finally this will be appended in your sample means. Sample means dot append sample underscore mean. Okay, so whatever is calculated here, this will get added to this list. Okay, so what we are doing over here, we are initiating a for loop which will iterate these many number of times that we have already defined over here, num samples, and in each iteration it will draw a random sample over here of the sample size that is mentioned 50. Okay, and it will calculate the mean of this age column, and then it will append that sample mean to this list, and it contains the means of 1000 number of samples that we have taken from this age column. Okay, so now in order to plot the histogram, we would need the min and the max in order to specify the range for the x-axis of the histogram. So we will calculate the range. So for that we can write min underscore sample mean, sample and mean. So this would be basically calculating the minimum of the list over here that we have obtained. Min sample means, likewise max underscore sample underscore mean. So that will store your maximum of these sample means. So this basically would determine the range for the x-axis in the histogram. So you can now decide the size of this figure or the size of the histogram that you want. So plot dot figure we will write, and in this we will mention the figure size to be of suppose 10 by 6. So we write it over here, and so here itself we can write the command for your plot the histogram of the sample means with this specified x-axis range that we have defined over here. So we will write plot.hist plt. So we are using this matplotlib over here, and .hist will be used for your histogram as we have studied this earlier also. So here we will write the sample means. Basically this is what we want to because this is what we have this list over here, right? Sample means. Then we will write the bins. How many bins do we need? Suppose we need 20 bins, and we can make the edge color as black, suppose. Then we mention the range. Range would be min sample mean to max sample mean. So let me just mention it. Okay. Next will be your density. So density we want to keep it as true. So basically this would normalize the histogram that we are drawing, so that the sum of the area under the bars that you see, that would be 1. If you keep the density as false, then it would just plot the actual count of the data points in each bin. Okay, so we are basically trying to scale your heights of the heights of those bars. So here let me just write density is equal to true, and if you want to add transparency to the bars, you can write alpha is equal to 0.6, and you can finally label it as sample mean. So this is how your histogram is looking like. Okay, so the x-axis you have specified already, it will go from the minimum to the maximum. Okay, in this case we have used 20 bins, as you can see from here. The color is blue and we have edges we have made as black. Okay, this is the histogram that you have drawn. Now suppose you want to overlay a normal distribution curve over this in order to understand and compare it with the normal distribution curve. So for that we first need to calculate the mean and standard deviation of the sample means that we have obtained over here. So for that let us just write these steps. Mean underscore, so we want the mean of the sample means that we have already calculated. So again we will use this numpy, and from there mean function will be used to find out the mean of these sample means. And for again for std I am just writing this for your standard deviation, np.std you can write here, and here you can just write sample underscore means. So this would calculate the mean and standard deviation of the sample means list. Okay, so this would describe basically the central tendency and your spread of the sampling distribution. Now with this mean and standard deviation of the data set, we now generate values for the normal distribution curve. In order to do that, we will write this steps over here. So we are generating basically, let me just write generate the values for normal distribution. So x will be, so numpy library, so it will use line space, sorry, spacey. So here now we would first of all mention the min sample mean. So minimum of this min sample mean comma max sample mean, comma 100. So here basically what we are trying to do is we are trying to create the values for the x-axis of the histogram. Okay, and so basically the range of the sample mean. So it will start from the minimum, it will go up till maximum, and 100 number of points. This is basically denoting that we want 100 evenly spaced points to be within these minimum and the maximum range. You can change it obviously. So when you write this line, so this is basically creating an array x that you have over here. So this would represent a range of x values for the normal distribution curve, and it will be used as the x-axis. Now you want the corresponding y-axis, okay, for the normal PDF. So you can write y. For this we will write norm dot PDF. So if you can recall, we have imported it over here from SciPy. So we are using it to draw this normal PDF. So norm.pdf, x will be the array of x values that we have generated just now. Then we will write mean underscore sample underscore means that you have found out here, and the standard deviation, std underscore sample underscore means. So minimum is this is the mean of the sample means that we have just now calculated, and this is the standard deviation that we have found out. So this line would basically calculate the corresponding y values based on the normal PDF for each x value that you have over here. So these two are basically used to this curve basically can be plotted in order to visualize the theoretical distribution of the sample means under the assumption of the normal distribution. So now we can finally plot the normal distribution curve. So we will use again this plt.plot for our purpose. So x is your x-axis, y is there, and then suppose you want a red dashed line, dash, that is why I'm writing 2 dash over here, and this is what you want, and you want the label to be suppose the normal distribution curve. So you can write normal distribution, and then suppose you want to add the sample size also to the plot. So you can use this annotate function from the matplotlib library. So we will write plt dot annotate. So we want the sample size f, so we are using this f string. Okay, we have used and explained this earlier also. So sample size, so first it will evaluate this, and then finally it will print this string sample size. Now we want to write this xy coords basically tell you where to place this sample size. Okay, so if you are writing xy, so let me just complete this. Xy over here is point, suppose you want it 0.7 and 0.9, and then xy coords is equal to axis fraction and font size suppose is 10. So here this annotate function will basically add the sample size to the plot. So for here we will first be writing the sample size that we are using. It will evaluate this sample size from the above lines, and then it will substitute it over here. Xy basically it will specify the coordinates where this annotation will be placed. So if you are writing 0.7, 0.9, these coordinates tell you that it will be positioned at 70% of the width and 90% of the height. So basically here this portion, that is the bottom left corner, this is 0, 0, and the top right corner is basically your 1, 1. So you can place wherever you want, and you can change these coordinates to see how it will change. And basically here this parameter over here, it is going to specify that the coordinates that you have provided over here, they are in the relative units of the axis of the plots. So when I have written it together, it is now running and giving you in this way. So X label is sample mean. I've written Y label as density over here. Title is sampling distribution of sample mean. Legend we are showing over here, and this is plot.show. Okay, so overall what we have done over here is that we have performed like bootstrapping to basically estimate the sampling distribution of the sample mean. So we first visualize it using a histogram, and then we overlaid a normal distribution curve and added relevant labels and annotations to the plot. So you have written sample size as 50, and if in case you want to vary it and see here, suppose let me change this over here 100 and run it. So this is how it will look like. Okay, so you can see that it is now a better curve as compared to earlier histograms. This is now looking better. So basically, as you increase the sample size, your sampling distribution of the sample mean would be approximately normal. So here this legend is coming this side, so you can alter this here by the command for the plot that we have done. So here I can just increase the size, plt.figure. So here let me just mention the fig size, which is suppose 10 by 8, and then run it. Okay, so normal distribution, sample mean distribution, we can change the coordinates of this one. We can suppose make it 0.8 and this one as 0.8. You can see that by changing these coordinates, you can change where you want this sample size thing to come. So this was all about the sampling distribution of sample mean. So now we will basically iterate a loop. So let us start this for loop. So for loop over the sample sizes. For n in sample size, sample means is this. Okay, so it will create an empty list to store the sample means for the current size. Okay, suppose here it picks 10, so here we have created an empty list. So basically what you have done earlier for sampling distribution of sample mean, this would be a sub part of that, because there we drew this histogram and the normal probability curve for a single sample size at a time. So here we basically want to show you that if you change the sample sizes, if you take a larger and larger sample, how the histograms would change. Okay, and how it would be depicting the normal distribution. So for that we first need for n in sample size, so basically it would create an empty list to store the sample means for this particular size that it has taken. Now it will again, we will create a for loop over here for suppose this in range 1000. Sorry. Okay, so here we are going to loop over 1000 times to draw samples and calculate their corresponding means. Okay, whatever sample size it has picked over here, for that 1000 samples would be taken. So once, let us see how to draw the sample, the same thing that we have done earlier. So sample underscore sample is equal to, so here we have saved your data is df. Okay, the data frame is df, so let us just use that, df dot sample n. Okay, so it will draw a random sample of size n from this OTT dataset. Then we will calculate the sample mean. Sample mean would be this way, sample, we will write age over here. Okay, and then we would apply this mean function. So it will calculate the mean of that sample, and then we will write sample underscore means dot append. So this would be finally appended to the sample means list that you have already created. This one first it will be added. So let me just complete this one, sample underscore mean. So this one would basically, here if you see, for n in sample sizes, sample means it has created an empty list. Once this size has been selected, then it will go through this for loop and it will calculate all these things, and then this will be finally stored in the sample means, this overall list also. This finally would be updated. So this would be sample underscore means underscore all sizes dot append So this would basically store the sample means for the current size. And after calculating sample means for all 1000 iterations for the current sample size, this list of sample means of all sizes would be appended. Now based upon this, now you can plot your histogram. So plt.hist. Here we would write the sample means that we want. Bins, suppose you want 20, and alpha is 0.6, and label we want as f, sample size so this n will be first evaluated and then printed. Okay, so you can add labels also over here. So we know all these parameters over here, right? So for each sample size, it is going to print your it is going to give you a histogram. 20 bins and transparency is 0.6, and it will have a label as this. Okay, so now if you want to add labels, so it will be plot.x label. So let us keep it as sample mean. Next we can write the y label, plot.y label. So there we could keep as, suppose, frequency because of this. And then finally we can have this title. Send CLT, we can just write CLT visualization. Okay. Next plt dot legend. So you see how your histograms have come. If you see in this legend over here, blue, the first one is the sample size 5. Okay, so this outer histogram that you see, it has a wider spread. So the sample size is 5. Next is 10. So this inner second one, you see this orange color, this is your sample size 10, histogram corresponding to that. And then for 20, this green, finally you have this one as 100. Okay, so you see that as you are increasing the sample size, the distribution is approaching your normal distribution. Okay, so you will get a perfect normal distribution if you keep on increasing the sample size. Okay, so if you just plot the population itself, then obviously if it is skewed, you will get a skewed data. But rather if you take the keep on taking large number of samples and when you increase the sample sizes also, then and you plot their sample means, then basically it will be normally distributed. And you can see that difference over here so clearly. So you can compare different histograms of sample means for different sample sizes in this same plot over here. Now if suppose you want to create a separate figure to plot the PDF for sample means. Okay, so for the same thing, if you suppose you want to see in the terms of PDF or the curve of that, so let us just add over here. We can write, maybe here only I can write, create a separate figure. So this would again be, figure size would be this. Now since you can see that we had different sample sizes, okay, so we need to create a for loop that will iterate over different sample sizes and plot the PDF for each size. So for this we will first of all initiate this for I n in enumerate, sorry, this will be I, this is n, in enumerate, and here bracket we will write sample sizes. Okay, this is what we had initially, sample sizes. So here we are initiating a for loop over here. Now here what it is doing, I is the index for these 5 sample sizes, okay, because there are 5, so n will be the sample sizes, 5, 10, 20, 50 and 100, and I would be the index. So it would iterate over each sample size in the sample sizes, and this enumerate function is basically used to obtain both your index I and the value from the list. Okay, so here we will now calculate the mean sample means would be calculated using your NumPy library. So np mean function, sample means of all sizes, so let me just use from here, and here we would write I because that would be the corresponding index. Okay, so if it is choosing the 5th sample size 5, it means index will be 1, otherwise it will vary. Okay, likewise we can also calculate the STD of the sample mean, standard deviation. So again we would use the same logic, and here sample means we can just copy it from here. So for each sample size you will calculate the mean and standard deviation. Now we are going to generate values for the normal distribution curve. Generate values for normal distribution curve. As we have done earlier also, we will use that same thing. X is equal to np dot line space. So here we will write the minimum of the sample this sizes. So let me write min of this particular one. Similarly, there would be maximum. So we are specifying the range for the x-axis basically. Maximum, it would go up till the sample means, again we can just write here, and we want 100 equally placed points in between. Likewise, the corresponding y values will be calculated. So for y, it will have norm.pdf. So here we will write x. It will be plotted for, it will take x values as the input. So x, and then mean of this. So mean will be this one, and with standard deviation we would mention. So now finally you can plot the PDF curve. We are ready to do that. plt.plot. here it would be x comma y label sample size is equal to this, and we can also add labels and legend for this. So it should be here. Finally, these things we can copy from here. So we want the x labels as suppose sample mean. Here we want the y to show that these are the PDFs, and we can write here the title can be PDF probability density. You can just write the small PDF curves for sample mean. So CLT visualization basically would come here, and then PLT. Finally, we will display this figure. Okay, so this is what you get over here. Okay, so these are the histograms, okay, for central limit theorem, and here these are the PDF corresponding PDF curves. So you can see that this one sample size of size 5, this is very wide, right? This is very spread is more in this case. Whereas when you are increasing the sample size, you can see that there is less variation. Standard deviation is less in this case as compared to the other ones. Okay. And so basically you can say that the values are very close to the mean. Okay. In this case, the values are very much far spread from the mean in this blue one. Okay. So we have got a set of these PDF curves, one for each sample size, and we can see that how the distribution of the sample means basically changes as the sample size varies. And this is basically your central limit theorem, which states that sampling distribution of the sample mean becomes approximately normal as the sample size increases, regardless of the shape of the population distribution.